Hi, everybody. Today we're on Unit 7, Lesson 3, and it's really just a review of some of the basic things you should know about log functions from your algebra class. So we're going to start today we're going to be given a function f of x equals 2 to the x, which is an exponential function. I want to sketch f of x, I want to sketch the inverse, and then we want to come up with an equation for the inverse. So to sketch f of x, remember when we're sketching an exponential function, we really only have to worry about 2 points. We have the point 0, 1, and then 1, whatever the base is. So in this case, it would be the point 1, 2. Now, if you don't remember that and you want to make yourself a table, that's fine. 0, 2 to the 0 is 1. When I plug in 1, 2 to the first is 2. It's perfectly okay to have to set up a table. And remember, our exponential function is shaped like that. Okay. So this is y equals 2 raised to the x power. Okay. And we studied that a couple of days ago. We know the domain is all reals, the range y is greater than 0, etc. Now, when I go to sketch the inverse, remember, the inverse is a reflection. When we're working with it graphically, it's a reflection in the line y equals x. So I could put that line y equals x in my graph. And then to get the ordered pairs, all we have to do is switch the x and y values. So this would be the graph of the inverse, and I'm going to switch each ordered pair, 1, 0, and 2, 1. And I can plot those new values, 1, 0, and 2, 1. And this becomes the graph of the inverse function. I could call it y inverse, f inverse. It's really interchangeable. Okay, so easy enough to graph. Now let's think about how we can write the equation of the inverse of this function. So if we go back to, what our rule is, right? If we start with y equals 2 raised to the x power, and we want to write the equation of the inverse, we're going to switch x and y. And now we have a little bit of a problem because our y is stuck up in that exponent and it's kind of hard to write it. We need to get it in the form of y equals. Okay. So this is basically where mathematicians kind of came up with this concept that the word logarithm means exponent. So a logarithm is a power. So they use this concept to help them rewrite these equations. So I'm just going to kind of write it here real quickly. Log equals, and if you think about it, what's the exponent in this rewritten, right? This inverse function, log equals y is the exponent. And then 2 is going to be our base. And x is what we're going to call the argument, but it's the answer to the exponential equation. I know it sounds weird, so we're going to summarize this again in just a minute. However, x equals 2 to the y can be rewritten as y equals log base 2 of x. Okay. So what's important to mention here is that this guy here on this side, this is an exponential function. And then we take the inverse, and this guy over here is a log function. This top form is the exponential form of the log function, and this bottom form is the log function, you know what I mean, that written in log form. So it's really important to understand that when you have a log function, it can be rewritten as an exponential, and this is the same, these two mean the same thing. So one more time, we're going to put it in a more general form. if I start with y equals b raised to the x power, and I take the inverse, in other words, I switch x and y, the result is x equals b to the y, or y equals log base b of x. Again, this is an exponential function. Okay, so over here, I'm like in exponential land. And this is, each of these are log functions. These two are equivalent forms. Okay, so they both mean the same thing. So now we should understand that a log function can be defined as the inverse of an exponential function, and a log is just another word for exponent. So the graph of a log function, just like the exponential function had many characteristics, the log function will have many characteristics. So I'm just going to go through a few of these. Okay, so this is a general exponential. Here's my line y equals x, and this is a general log function. Okay, so we have exponential, a log, and we're just going to kind of describe these. The purple line is the exponential, once again. The red line is the line y equals x, and the orange line is our log function. So right now, if we want to summarize some characteristics of our log function, we could say y equals log base b of x. The base has to be greater than 0, and the base cannot equal 1. And the domain of our log function, now if you notice, our domain is the restricted. Our domain is all x values greater than 0. Now our range, and we should connect it to the domain of the exponential. The domain of the exponential is all reals, and the range is y is greater than 0. Our range in our log function, if you notice, it's going to go up. It's going to go up slowly, but we're going to hit all the y values. So our range is going to be all real numbers. And this is important because what did we say about inverse functions? We switch x and y, or we switch domain and range. And if you see here, the domain and range get switched. Okay, so that's like kind of important. Instead of the horizontal asymptote at y equals 0, instead we're going to see a vertical asymptote in our graph. So notice how the vertical asymptote is there instead, and that's going to be at x equals 0. We're going to have an x-intercept at 1, 0 in its most basic form. We're always going to contain the point b1, similar to the exponential function. And lastly, there's going to be no y-intercept to a log function in its most basic form because of the fact that we've got that vertical asymptote there. And just to kind of show you how our functions can be written, when we have our exponential function, y equals 2 to the x or y equals e to the x, we're used to seeing those. They're easy enough to understand. Possible equations for log functions, y equals log base 2 of x, or y equals ln of x, and this is a special case for log base e. So the inverse of e is ln. And all of these things should start coming back to you from last year. We have 2 more important things that we can talk about before we move on to actually doing work. They're also, so we have the common log and the natural log, and you can evaluate both of these in your calculator, and we will at some point in time, just not yet. So our common log is log base 10 of x. And you guys will see that frequently. If you don't see a base there, it's just like a square root sign. You don't see that little 2 in the hook, just means take the square root. When you don't see a base, it just means it's base 10. And the natural log is log base e, which we rewrite as ln of x. And both of these will become very, very important later on in the unit. Okay. So to sum up everything we've learned today, to get from an exponential to a log or a log to an exponent, follow this basic rule. So this is going to be one of the key things we're going to work on today, going back and forth. And we just want to remember log equals exponent. Okay. All right, so things we're going to do today. We're going to convert back and forth between log to exponential form. We're going to talk about the domain, and we're going to set up and solve some real super, super easy log equations. In our first set of examples, converting between log and exponential form, rewrite each exponential equation as an equivalent statement involving logs. Okay, so we're just rewriting this in log form. So I'm going from here to here. When I do this, I always use that in my head. So I just say while I'm doing it, log equals the exponent. The exponent is 2. The base is 4. And the only obvious place for that leftover number is right there, 16. And basically what this means is 4 squared equals 16. Remember, log gives us information about powers. E to the b equals 9. Oh, you know what? I should get rid of these two things to not confuse you. E to the b equals 9. Log equals exponent. Notice I gave myself some room there. I know I have 2 places to fill. I've got this base, and then I've got a number that I have to put there. My base is e, and the number is going to be the 9. When I see log base e, I'm always going to remember to rewrite it as ln. Both equivalent log expressions, exponential form, log form. Exponential form, log form. But they both mean the same thing. Now let's go in the opposite direction. We're going to start with a log statement, and we're going to write it as an equivalent statement involving exponents. And this, I just do a little circle job. I always just make a little circle out of these, right? I'm going backwards from this back in this direction. 5 squared equals 25. So log base 5 of 25 equals 2 is the same as saying 5 squared equals 25. ln of b is really log base e of b. And now I'm going to make my little circle guy. E to the negative third equals b. Once again, saying ln of b equals negative 3 is the same as saying e to the negative third equals b. Okay. So it's pretty straightforward. Next, we're going to talk about domain. Now, we're not going to focus a lot on the graph, okay? We're not going to be focusing on graphs too much. You might have to recognize one, but I'm not going to physically make you graph log functions, but you should understand that when you're working with log functions, because it starts with a restricted domain, we're going to have issues with the domain, right? So a log function gets put into that list of functions that has issues. Okay. Now remember, our log function is written like this, right? X is the domain, right? X is the x values, or in general, domain is our x values. Okay. When we're dealing with log functions, this piece here, no matter how simple or complicated it is, this expression is called the argument. So when you hear me refer to the argument, I'm referring to that expression, whatever, however complicated or simple it is. And to find the domain, we just set the argument greater than 0. Because remember, our original log function is greater. Our original domain is x is greater than 0. Okay? So we always want to kind of understand that. So when I'm solving this, when I'm trying to find the domain of y equals log base 2 of x plus 3, the base does not matter. The argument does. So I'm going to take and I'm going to set the argument x plus 3 greater than 0 and solve this. So the domain of this particular function is x is greater than -3. And remember, you're always allowed to write it in interval notation if you prefer. Either way is acceptable. In our second example, y equals log base 1/2. Again, the base does not matter. It's a log function, so it's going to, all the characteristics just apply. Argument greater than 0. Okay. And now you have to remember how to solve different types of inequalities. This is why we reviewed it in the beginning of the year. When I go to solve this, I see I have a quadratic. So I want to set it equal to 0. Find the values that go on the number line. Put the numbers on the number line. And quadratics are simple because you go back up to the original inequality sign, open circles, greater than shades out. Remember, with polynomials, x cubed, etc., you have to test each interval. But with a quadratic, you can do this little cheat. Less than shade in, greater than shade out. And our domain then simply becomes x is less than -1 or x is greater than 1. Again, you could write it in interval notation if you prefer. It's quite, it's okay just to leave it like this. All right, now let's remember, log gives us information on powers. That's the most important thing to remember. So if you notice, when you rewrite in exponential form, you're setting up an equation you can solve. So whenever we see either finding exact values or easy types of equations, basically, we want to rewrite it in exponential form, especially when we're not using a calculator. We have to rewrite it in exponential form. And then we're going to solve and check. Now with exponential equations, we didn't really have to check our solutions. Here we do, because when we solve, we're solving for x. And since our domain is restricted, we have to be very careful. So we just want to, we don't actually have to go back and evaluate, but you just have to make sure, your base and argument are greater than 0. And the base cannot equal 1. Okay. It's a really quick, easy check. So to practice, let's find the exact value of each of the following, again, without using a calculator. There's going to be times when we're allowed to, and we kind of have to know the difference. So log base 2 of 16, some of you may know right off in your head, okay, that since a log is a power, log base 2 of 16 is really asking you, what power do I raise 2 to get 16? And that answer would be 4. However, if you don't see it, it's no big deal. When you don't know something, you set it equal to x. Rewrite in exponential form. And once again here, you might see the answer right away, or you might solve it like an exponential and rewrite each side with a common base. And there you have it, x equals 4. Log base 3 of 1 over 27. Again, this means what power do I raise 3 to? I don't know what the power is, so I make it an x. Rewrite in exponential form. 3 raised to the x equals 1 over 27. Rewrite each side as a common base. Solve it. Oops. Well, no, I don't have. I'm solving. My x is after the equal sign, so I don't have to worry about checking my answer. ln of e cubed. So ln, I'm going to rewrite as log base e of e cubed. Now I rewrite this e to the x equals e cubed. So x equals 3. Okay. So there's some real easy ones that we, see. Now let's get a little tiny bit more complicated. We want to solve each equation. Remember, it's a simple log equation. We're just going to rewrite it in exponential form. I can't solve it with the word log there, but I can solve it if it's written like that. 3 squared equals 4x minus 7. 9 equals 4x minus 7. Add 7 to both sides. 4x equals 16, and I get x equals 4. Now, here's what I mean about the check. We just go in, since our variable is in the argument, we just say, if I plug in 4, will that be a positive number? 16 minus 7 is positive, so this works. If you got a negative number when you plugged it in, then you would have to reject your answer. ln of e to the negative 2x equals 8. So I'm first going to rewrite this in exponential form, but in order to do that, I kind of like to rewrite it. I'm not that good. I have to talk in my head. I always have to talk things through. So e to the negative 8. I'm sorry, e to the 8 equals e to the negative 2x. And now I can cancel my bases. And x is going to equal negative 4. And I'm plugging for something that I plug into an exponential function, so I'm okay with that. Okay, I can plug any number. I'll get an answer. Now, some of you may remember a little bit more from logs than others. Okay, so some of you may have approached that problem a little bit differently. That's absolutely fine. Okay, I'm just kind of going through what you would know by now to solve these. In example C. So I'm going to start by rewriting this in exponential form. X squared equals 64. When I take the square root of each side to solve it, hopefully you remember you get plus or minus 8. And if you didn't, you'd get lucky this time because you'd have to, now remember this is x equals 8 and x equals negative 8, but the base can't be a negative value. So we're going to reject that one. And our last example for today, log base 2 of x squared minus 4x equals 5, exponential form. 2 to the 5th equals x squared minus 4x. My resulting equation is a quadratic. 2 to the 5th is 32. So I'm going to subtract that 32 over. And this is going to become x squared minus 4x minus 32 equals 0. In order to solve this, we're going to factor. X minus 8, x plus 4. Now here's where we want to be careful. Remember, I only care about my solution. I can get a negative answer as long as it makes the argument positive. So if I'm going to check each one of these in my head, if I plug 8 in, 8 squared is 64. 64 minus 30, that's going to be positive. So I don't even have to do all the math. I just have to know it's going to give me a positive number. So that works. When I plug in negative 4 squared is 16. Oh, I feel like that shouldn't work. Negative 4 squared is 16. Oh, but it's going to be 16 plus 16. So that answer does work. So both of those numbers, when I plug them in, right? Negative 4 squared is 16. 16 minus negative 16 is 16 plus 16. So that one works. So even though I get a negative value here, as long as it makes your argument positive, you're safe. Okay. So I hope you have some stuff about logs coming back to you. Really very important to work through your homework tonight because you need just the repetitiveness of this topic to move forward. Okay. Thank you very much, and we'll see you soon.